But chapter 8, we talk about sequences, series, probability, that sort of a thing. We kind of move out of the algebra realm, and we're getting into some more, I guess it would be statistical kinds of things with probability and stuff like that. But you guys are familiar with sequences and series. A sequence in math, just like in English, a sequence is an order. It right here, it says it right here. A sequence means that something is ordered so that there's a first member, a second member, a third member, and so on. Right? There's a structure. You can think of a sequence as a function, right? I'm going to talk about two different kinds of functions. We're going to talk about arithmetic, which is 8.2, and geometric, which is 8.3. An arithmetic function is similar or is the same as a line, y equals mx plus b. A geometric is the same as, it's more of an exponential kind of thing. So when we talk about different words here, all of these things you guys are familiar with, what does it mean if something is infinite versus something that is finite? What does infinite mean? Goes on and on and on, never ending. So if you have an infinite sequence at the end of the numbers, it's going to go like this. It's an ellipses, dot, 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 and that means it just keeps going. A finite sequence has a beginning and what? It has an end. All right, we're going to talk about different terms of the sequence. The way that you name terms is A sub 1, that's term 1. That's term 1. A sub 2, that's term 2, and so forth. So if they want the 5th term of a sequence or the 25th term of a sequence, they want to know that term number. A lot of times you can think of it like this. Whatever the first term is, the second term, the third term, it's kind of like an XY chart. I'll show you in a second. But in a case with something very basic and very simple, I know this seems very elementary, but you need to show me these types of things. If it says write the first 4 terms in each sequence, well, remember n is your term number. So I want to know a sub 1, a sub 2, a sub 3, and a sub 4. I want to know the first 4 terms. So what am I going to do with 1, 2, 3, and 4? I'm going to plug it in for the n, because that's what I'm trying to find. So I'm going to say 3 times 1 minus 2. Well, it's 3 times 1. 3 minus 2 is 1, okay? So then I'm going to find the second term. I'm going to plug in 2 for my n. So 3 times 2 minus 1. 6 minus 1 is, what is it? Okay. Now I'm going to plug in 3. So I have 3. It's minus 2. I'm sorry. I was looking at the one above it. So 3 times 2 is 6. Minus 2 is 4, right? 3 times 3 minus 2. What's 3 times 3? 9. And 9 minus 2 is 7. And then I'm going to plug in 4 because I'm looking for the 4th term. So 3 times 4 is 12. Minus 2 is 10. So the first 4 terms of this sequence are 1, 4, 7, and 10. Just that simple. In the next one, formula looks a little different, but again, I'm still finding the first 4 terms. So a sub 1, a sub 2, a sub 3, and a sub 4. The first term I see is 3 plus negative 1 to the first power. Well, what's negative 1 to the first power? Negative 1, so 3 minus 1 is 2. So now I'm going to find the second term. So I plug in 2. So negative 1 squared is 1, plus 3 is 4. Good. So now I'm going to find the third term. So I'm going to say 3 plus negative 1 to the third power. What's negative 1 to the third power? Negative 1 plus 3 is 2. And then to the 4th power. So 3 plus negative 1 to the 4th power. Well, negative 1 to the 4th power is 1, plus 3 is 4. So in this case, the first 4 terms of this sequence are 2, 4, 2, and 4. Questions? Yes? No? Maybe so? All right, scoot along. Now, if you're finding the nth term of a sequence, now with our 8.2 arithmetic and 8.3 geometric, you're going to write rules, and you'll be able to find, when I say write a rule, you'll write, 3n minus 8. That's your rule. And if I want to know the 975th term, Instead of multiplying the term before it by 3 and subtracting 8, you just plug in whatever term number you're looking for the end. But I want you guys to look at this, all right? We're not going to fully solve and all this right now. I want you guys to just think a little bit. So right here, my first sequence is 1, 3, 5, and 7, right? You guys agree with me? Okay, would you agree with me that 1 is my first term, 3 is my second term, 5 is my third term, and 7 is my fourth term, correct? Okay. All right, now let's figure out, how did I get from one term to the next? How did I get from 1 to 3? I added 2, okay. How did I get from 3 to 5? I added 2. How did I get from 5 to 7? I added 2. What are you guys noticing about this pattern? How do you get from one number to the next? Each of them is just plus 2. You just keep adding 2. There's no like add 2 to the one before it, then subtract this. Just every single time we're adding 2. It's the same. It's constant. Everybody see that? Okay. This is what's called an arithmetic sequence, and we'll talk about that on Monday. But arithmetic means when you add or subtract the exact same thing every time. So, what is this? What is that? You guys don't know what that equation means? It's the slope-intercept, right? What is m again? M is the slope. And what is b? It's the y-intercept. What is the value of x at the y-intercept? 0, okay? All right, so let's think about this. The slope. That's what you do from one point to the next every single time, right? And it's always the same. So in this case, what could you equate plus 2 to? It's the slope. When you add or subtract the same thing every time, that's just the slope. So if you were writing this rule, you would say a sub n. Well, instead of x, what letter do you think we're going to use? Instead of x, what letter do you think we're going to use? The n. Okay, good. And then what would my y-intercept be? Given what I have here, a sub 1, a sub 2, a sub 3, a sub 4, what would the y-intercept be? Would it be your 0 term, your a sub 0? Do you guys agree with this? This would be my x's, this is my y's. So what would my term before 1 be? How would I figure that out? Why would you minus it?
Because it's consistently.
Yep. Since you're adding 2 to get above, to get the ones below it, you do the opposite. So if I subtracted 2, I get negative 1. Now again, we're going to work on this more in the coming weeks, but I want you guys to just start thinking a little bit. When you have an arithmetic sequence, when you are adding or subtracting the same thing every time, it's just the same as y equals mx plus b. It's just different letters. So now you're like, okay, well, I wrote this rule. So if I asked you what the 900th term was, you would just put 900 in for n. But in this case, let's just check to make sure we're right. Check this right here. The fourth term of this sequence is 7, correct? So if you plug in 4 for n, what's 2 times 4? 8 minus 1 is? Oh, well, that's what we got. So there you go. You just wrote the rule. So if you look at b, b is a little different. B is 2, 5, 10, and 17. Okay, well, how'd you get from 2 to 5? Add 3. Okay, so plus 3. How did you get from 5 to 10? Plus 5. How'd you get from 10 to 17? Plus 7. Are you adding the exact same thing every time? No. So this is not an arithmetic function. You can't just say, oh, well, the slope is this, and the y-intercept is this, and that's that. But you will be able to, in the coming weeks, we're not going to do this right now, but in the next couple of days, you're going to be able to figure out, okay, what did I do to get from here to here? What is happening every single time that's the same? Are you, okay, adding odd numbers. All right, I see that. So 2 times 2, well, no. 2 times 1 is 2 plus 1 is 3. 5 times 2, no. We'll come back to it. I just want your brains to work a little bit. We'll come back to it. All right, let's look here. Recursive. You guys aren't going to use recursive very often, all right? In a recursive formula, they have to give you the first term, and then you have to know the term before to find the next one. So recursive is kind of silly, because if I gave you a recursive sequence and I said find the 150th term, well, you'd have to know what 149 was first. So we don't use recursive a lot. Just want you guys to see what it is. If they tell you that the first term, a sub 1, is 3, this means the term before. So let me show you. If I want to know a sub 2, I want to know the next term. So I plug in 2 here. What's 2 minus 1? 1. So you have to have the term before it. So this is 2 times 3 plus 1, which is what? 7, right? So now how do I find the third term? I have to know the term before it. So I have to take this number and plug it in right here. So 2 times 7 plus 1 is 15. In order to find the next term, I have to know the term before it. So now it would be 2 times 15 plus 1. What's 2 times 15? 30 plus 1 is 31. Well, to find the fifth term, then I have to know what? The term before it. So all you're doing is just plugging in the term previous for a recursive. So what's 31 times 2? Plus 1 is 63. So recursive's not really very useful to us, because in order to find the next term, you have to know the one before it. So it's kind of silly. You'd have to do this. If I wanted the 150th term, you'd have to do this 150 times. It's not just a formula you can just plug in to find a specific term number. So we don't do much with recursive. I just want to see it. All right, we're going to skip Fibonacci for a minute. I'm going to come back to it when everybody's here. But we're going to talk about something called factorial notation. All right, this is super simple. If I say, that does not mean 5. It's not like a really excited 5, right? What factorial notation means, and there is a button on your calculator, I'd have to show you guys where it was, that'll do this for you. But factorial notation means the number that is next to the exclamation point is where you start. And then you multiply every number below it together. So 5 times 4 times 3 times 2 times 1. If you had 7 factorial, 7! It's really 7 times 6 times 5 times 4 times 3 times 2 times 1. You guys are like, do we have to write that out every time? Yes. Just suck it up. I'm not going to give you 100 of them. But factorial notation is very basic. You just have to know what, like if you didn't know what that meant, you'd be like, what? But now that you know what it means, it's like, oh, no big deal. You're just multiplying everything below it. So if you come to a question like this, says write the first 5 terms. Okay, fine. Where do they want you to begin with? They're telling you to begin with what? N is 0. So you're going to find a sub 0. We're going to find a sub 1, a sub 2, a sub 3, and a sub 4, since they told us to start with 0, right? So when I write those little sub numbers, little 1, little 2, little 3, that's what you plug in for n. I'm looking for the 0 term. So literally, guys, you say, okay, 2 to the 0 power over 0 factorial. What is 2 to the 0 power? 1. And what is 0 factorial? Anybody know? 0 factorial actually equals 1. 0 factorial equals 1. Like anything to the 0 power equals 1. So that's good information to know. So what is the first term here? It's 1. So now I'm going to plug in what number? I'm going to plug in 1s everywhere I see an n. So I have 2 to the first power over 1 factorial. Well, what does that mean on the bottom? 1 factorial. 1 times everything below it, which is 1 times 1. Only the even positives. So this is just how much? 2. No big deal. So now I'm going to say, okay, fine. I have 2 to the second power over n factorial. So this really means 4 over 2 times 1, which is 2. So my answer here is 2. So now I'm going to plug in 3. So I have 2 to the third power over 3 factorial. Okay, now we're getting a little, not harder. You guys can all handle this. But 2 to the third power on top, this means 8. And then this is 3 times 2 times 1. Do I have to write the 1? No. If you guys don't, if you just stop at 2, that's fine. Because the 1 doesn't really mean anything. But what this simplifies to is 8 over 6, which is what? 4 over 3. Okay, so now we're going to find the fourth term. Well, that just means I plug in 4 for all of my n's. So quickly, these numbers get a little bigger because factorial means multiply everything below it. So 2 to the fourth power is 16. And then 4 factorial means 4 times 3 times 2 times 1. Now, when the numbers get a lot larger, you can just multiply everything together. But again, if you don't have a calculator, things can get a little hairy. So you can always cancel things numerator to denominator. I can say, well, 4 goes into 4 one time, and 4 goes into 16 how many times? 4, right? What else could I simplify? 4 and 2? 2 goes into 2 once, and 2 goes into 4 how many times? Twice. So what is the answer here? 2 over 3. Good. So get in the habit of canceling out factors, because if you don't have a calculator, that might be a little difficult when the numbers get a little bigger. We'll talk about B later when everybody's here. Let's look at A. This says 8 factorial, which means 8 times 7 times 6, 5, 4, 3, 2, 1, over. Is 2 factorial times 6 factorial the same as 12 factorial? No. You cannot, those are two separate things. That says 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. You cannot just say, oh, well, 6 times 2 is 12, so it's 12 factorial, because that then becomes 12 times 11 times 10 times 9. So just keep them separate. So I'm going to write my 2 factorial and my 1, and then I'm going to write my 6, 5, 4, 3, 2, and 1. Now, yes, you could multiply everything together and then simplify, but what do you notice about factors on the top and factors on the bottom? 1's cancel, 2's cancel, 3's cancel, 4 cancel, 5 cancel, 6. Anything else cancel?
Oh, that's it.
Yep. 2 goes into 2 once, 2 goes into 4, sorry, 8 how many times? So this whole thing simplifies to what? 28. All right, make your life easier. If you have a problem like 14 factorial over 11 factorial, you guys are like, oh my God, I have to write out 14, 13. Do I really have to write all of it out? What can I stop at? I could stop at 11, couldn't I? I could say 14 times 13 times 12 times 11. Why can't I just say, oh, 11 factorial? Because what's on the bottom? 11 factorial. Do you guys notice all that factorial means is all the numbers below it. So if you have the same numbers on top and the same numbers on the bottom, you can just stop at that one position. You can't just leave it as 11. You have to have the exclamation point, because that denotes, oh, everything below it. So then you could cancel here and then multiply. Does that make sense? Yes, Felipe, question? Or not? Okay. All right, last thing. Just when you guys are like, this isn't so bad, then we get to, seriously? Even when someone says, it's all Greek to me. Look, it's Greek. This is summation notation. Some of you will be very familiar with these Greek letters once you start your freshman year of college. You'll go around and see everybody's... you'll try and figure out what fraternity or sorority everybody's in by the letters in the back of their cars. So you'll get to know it. But guys, summation notation. All right, this is sigma notation. That's the Greek letter sigma. What does sum mean? Addition. So when you add stuff together, right? So sum. So this summation notation, the Greek letter sigma, I have a very tough time writing it. I don't know why. Every time I do it, it just looks weird. But there's parts of this that are important. The index of summation, n, is the upper limit of summation. Okay, this is the upper limit. And down here is the lower. What I want you guys to think of with that is start and stop. This is a super easy concept. Summation notation just means, hey, I want to know what all of these terms are what the sum of it when I add them all together. Meaning, summation notation, okay? They gave me an expression that they want me to use. What number do they want me to start plugging in? 1. And where do they want me to stop? 5. And what do I do with all the answers that I get? I add them together. So just very, very simply, this is how I want you to do this and show you work. 3, and I start with 1. Then I have 3, and I plug in 2. Then I have 3, and I plug in 3. Then I have 3, and I plug in 4. Then I have 3, and I plug in 5. Why did I start at 1, and I stopped at 5? My lower limit is 1. What's my upper limit? 5. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. Now I sum those up. What's 3 and 6? 9. 9 and 9 is 18. 18 and 12 is 30. 30 and 15? 45. That's your sum. Is that awful? No. 5 seconds ago, when you didn't know what any of that meant, you're like, what am I supposed to do? Now you're like, oh, okay, not bad. Right? All right, let's look at the next one. All right, again, they gave me an expression to use, correct? They gave me a lower limit, and they gave me an upper limit. What is the lower limit? What do they want me to start evaluating with? They want me to start evaluating with what number? 3. And where do they want me to stop? At 6. There you go. So to show me your work, you would say, okay, 1 plus 3 squared, 1 plus 4 squared, 1 plus 5, squared, and 1 plus 6 squared. Guys, be careful. That squared is inside the parentheses. So you square the number first, then add 1. So 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 5 squared is 25 plus 1 is 26. 6 squared is 36 plus 1 is 37. Now I find the sum of that. This is your summation, so add them together. What's 37 and 26? 63. Plus 10 is 73. Plus 17 is 90. There you go. Now, on WebAssign, you might have one. Here I go. I'm going to try and do it. Very strikingly similar, right? They might tell you that I is 1, or I don't know why I wrote a T. I is 1, and the upper limit is 8, and then this is the number that they gave you. And you're like, wait a second, there's nothing for me to plug into. All this means is you have 8. How many times? How many times do I have 8? 8. So you're going to say 8 times 8 is 64. Whatever this number is, you multiply it by that one. When it's just a number by itself. You'll see that. So now you're not like, oh, I don't know what to do. Just multiply those two together. Sound good? All right, that's it.